Welcome to the very basics of radio astronomy. I want to do a simple video on the subject before I go on to cover it in more detail. What we're going to do is go through three key points. Firstly, what is radio? Secondly, why look for it? And thirdly, how? So part 1, what is radio? So we start our journey with a man called James Clerk Maxwell, who realised visible light was what we call electromagnetic radiation. We now know light is an incredibly complicated thing. It's a description involving some physics of waves, some quantum mechanics. All we need to know is this. Light has properties like a wave, for example a frequency, a measure of the rate waves pass through a particular point, and a wavelength, the physical length of a wave. And being electromagnetic, it has to do with electromagnetism. Now, because Maxwell realised that light was this electromagnetic wave, if you think a bit about electromagnetism, you get to this idea, well, what else is there? Why are we only seeing this visible light? Because there's nothing in Maxwell's mathematics that says that light could only be in those frequencies that are visible. And then very quickly other people sort of took up this challenge, and they found out that you can find electromagnetic radiation in these other frequencies. For example, Heinrich Hertz made and detected radio waves. We also found later on, for example, X-rays, UVs, various other frequencies of light. Broadly, radio is frequencies of order 30 Hz to 30 GHz, with 1 Hz being one cycle of the wave per second. They have lower frequencies and longer wavelengths than visible light. So that's what radio telescopes look for then. But why go for that band? Okay, firstly, you might find new physics or see things that you don't see invisible. Obvious example of other frequencies letting us see new things is, for example, infrared imaging, which makes a sort of heat map that allows you to see people in complete darkness. So maybe if you look in radio in space, you'll see things that you don't see in the visible. But there's another good reason as well, which is worth talking about. The Earth has an atmosphere. Some light is blocked by this, some is distorted, some is let through. So to borrow from the quantum mechanics side of light, there's many possible interactions between a bit of light and particles in the atmosphere, and these can depend on the frequency of the light. For example, ozone absorbs UV light very well, as anyone with a bit of knowledge about climate change could tell you. This idea of destroying the ozone layer became very important. Carbon dioxide absorbs well in the mid and far end of infrared, and water vapour absorbs light of various frequencies. So what I'm showing you is simplified but good. It's a graph of the key point of radio astronomy in effect. It's a graph of roughly how much light would get through the atmosphere at a given frequency. So you see visible light gets through with a bit of distortion. Infrared is very restricted. But there's this beautiful space where radio waves can get through easily to the Earth's surface. And this helps explain, for example, the prevalence of radio in communication. If you want to send signals across Earth, use radio. It also explains why this is of interest for astronomy. We have a whole range of frequencies of light which might be coming from space, telling us about what is out there, and it gets to us on the Earth's surface. Now what we need to do is build a telescope to look at it. And to do that, we take on from the wonderful work on radio as a communication tool. So what do we need to build this radio telescope? First, we have our antenna. We need to get from radio waves to a measurable signal. Step 1, convert the radio waves that hit it into an alternating current. We're stealing from Maxwell again here, his idea of forms of light as electromagnetic radiation. We can convert that to a current which is electric via various bits of complicated physics within that antenna. Once we have that alternating current, we can start to work on that current, have a material which is an electrical conductor, and the radio waves will induce a voltage on it. Using knowledge of physics and mathematics, we can get from here to a decent AC current for our next step to work. Now, in astronomy, what we usually use is called a parabolic antenna. It's a big dish that channels radio waves onto a smaller antenna referred to as a feed antenna, which is held at the focal point of the dish. Essentially, any radio light that hits that dish should be focused towards that antenna, so you don't have to have only the stuff that hits that tiny point. You can have this huge range to collect signals from. Next step is our radio receiver. We need to turn this small alternating current from the antenna into something useful. So, in that sense then, the receiver does a few good jobs for us. One is filtering for the frequencies we're interested in. This antenna is taking a current that's caused by a wide range of frequencies, and we need to trim that down to something of interest. We also want to amplify the signal to something we can make sense of. This is very important in communication, as they then need to demodulate. If you're using radio to communicate, you take a useful signal from a carrier wave which the device receives. In radio astronomy, your receiver is also doing a lot of amplification. That's a lot of its main job, because the signal coming from space is very tiny. It's coming from an object that's an enormous distance away, and only a very small amount of the radio emitted by that object is going to get to Earth. So you have to have very good amplifiers in your radio telescope to get this up to something that we can make sense of. Once we've done that, we've got a radio signal and we can start doing interesting things with it. Nowadays, that generally means converting to digital so that we can see this on a computer, and once we've got it on a computer we can bring in an enormous amount of mathematics to bear on this signal that we've got to try and find out about it. So that's the very basics of what radio is, why we look for it, and the basics of a radio telescope. So now I've made this, what I can do is talk more about the fundamentals of radio astronomy, with this as a simple sort of point to build from. Till next time, goodbye.